How's it going, everybody? Darren here, aka Dr. Dev, and welcome to another Learn to Program using C#.NET video. If this is your first time here and you want to learn how to program in C#, or you're just looking for videos with tips, tricks, and best practices in the world of programming, then start now by subscribing and clicking the bell so that you don't miss anything. In this episode, I'll be teaching you guys about branches. And no, unfortunately, I'm actually not talking about the ones on trees, but instead the ones that we write in our code. So in the programming world, what are branches? Branches are what we use when we want to make the path of our code's execution change. Up until now, we haven't used any branches. Our code has been pretty much executed from the top to bottom entirely. But when we want to only execute certain parts of our code under certain circumstances, then we use branches. Now, there are a number of ways to branch the execution of your code, and the method that you use to do so will vary depending on your needs. But in this video, we're going to be pretty much focusing on the usage of the if-else statements to achieve branching. So let's open up the solution that we've been using for the past few episodes. And you'll see that it opens up here where we wrote the double and decimals code for the previous one. So let's just go ahead and delete all of that because we will not be needing it for now. And of course, I will keep the read key line in there so that our code doesn't exit. So let's write some code to create two simple integer variables, add them together, and store the result in a third integer. Sounds pretty familiar, I know. It's basically what we did in the integer episode, but there's a reason for it, and I'll explain it once we do it. So I'll go ahead and let's say I'll create an integer. I'll call this one first, and I'll give this one a value of, let's say, 5. Now I'll create a second integer. I'll call this one second, and I'll give it a value of 15. And then I'll create a final one called the result, and it's equal to first plus not the multiply, first plus second. So now we have a variable called result, which has a value of 20 because it's going to add 5 and 15 together. Cool. So what we did in the previous episode was we've said console.writeLine, and we would basically just say, I don't know, we created like an interpolated string. If you don't know what interpolated strings are at this point, you definitely need to check the video out about it that I made. I will have a link to it in the description, so check that out if you don't know. But anyways, I'll create an interpolated string here, and I'll just say the result is, and then I'll put in my variable. So the result is result. And if we go ahead and start up now, we get the result is 20 in the console. Perfect. This is nothing new. As I said, you guys are very much aware of this. Grand. So I'll close it down. But here's the interesting question. What if we only want this console.writeLine to execute under a certain condition? How do we do that? Well, that's where the if statement comes in. So the way it looks is pretty much like this. We write the if keyword, and then we do open and close parentheses. And inside of these parentheses, we specify our condition. And if that condition is true, so once it gets evaluated, if it's true, then whatever precedes the if statement gets executed. So in this case, if I say if result, let's say if I wanted the result to be greater than 25, I would say if result, and then I would use the greater than symbol. So if result is greater than 25, and then I just do open and close curly braces, and I'll wrap those braces around my console.writeLine. If you remember, guys, I talked about scope in the first or second video of the series. I can't remember. And I did say that I would talk more about scope in the future, and I will. But just for the purpose of this video, remember that scope in this case means that whatever is within these two braces belongs to this upper condition. So in this case, if my if is evaluated to true, right? So if my result is greater than 25, then everything inside of the scope of the if statement will be executed. So I could put in multiple lines of code in here. You know, I could put in like blah, blah, blah. I could put in whatever I want in here, and all of that will get executed if my if statement gets executed. So in this case, we're saying if result is greater than 25, then execute everything within these blocks. In this case, we've only got one line of code, of course. So what happens if we run our code now? Let's have a look. We don't get anything. Interesting. The result is 20. It checks to see, okay, when it hits the if statement here, it says, is my result greater than 25? Well, no, my result is 20. So it actually skips the execution of the code within this block. It completely skips it. So let's try now to change our first variable up here. And let's increase its value to be also 15. So now when we add them together, the result will be 30. Well, what would we expect to happen? It would check, is result greater than 25? Yes, it would be. So we're expecting this console.writeLine to be executed. So let's have a look. There we go. We now see the console.writeLine. So we know now that the execution path of our code can change depending on certain conditions that we have specified in our application. And this is extremely powerful. So let's talk about what's really happening here under the hood with this if condition statement here. So when we do this kind of check here, so this result greater than 25, what that's called is an expression. And an expression contains one or more operators and two or more operands. And in this case, the operands are our result and our 25, which is just a constant integer. And the operator is the greater than. So what's happening here is the operator for greater than is saying, is the operand on the left-hand side of me greater than the operand on the right-hand side of me? So that's what's happening there, right? And that's an expression. And once it gets evaluated, it's either going to return true or it's going to return false. And that's called a Boolean. A Boolean is a variable, or it's a type, I should say, which can contain a value which is true or false. Up until now, we've learned about strings, we've learned about doubles, decimals, and integers, but there's also Boolean. And Booleans are used, as I said, for true and false. And this goes to show the power of the if condition with Booleans. So let's have a look at how we can create a Boolean. We can basically change this a little bit to start messing around with Booleans. So to create a Boolean in C#, we write the bool keyword. And then we give a name to the variable, just like we do with any other type. So let's call it is greater than 25. I cannot spell, of course. So is greater than 25. And we can give it a value, and this value can only be true or false, as I said. But we can also give it an expression. So instead of just giving it a true, for example, we can actually give it an expression. And as I said a few minutes ago, this is an expression. So I can actually give it that expression. So we can see there that I'm actually giving my Boolean variable an expression. So what's happening here is my expression will be evaluated. It'll check, is result greater than 25? If it is, my variable will hold a result of true. If it's not, my variable will hold a result of false. And now, in our if condition, we can actually just put our variable in there. So now we can say, and then basically what this just shows is exactly the same thing as before. And it just says, if my Boolean variable is true, then execute my block. Otherwise, skip it. Simple enough, but powerful. So if you want to talk about it from a terminology point of view, what we have done here is created one branch in our function. So in our main function, this is one branch. And a branch is basically defined as a single path of execution that can occur within the execution scope of the function. So this is one possible branch. And in this case, it's the true branch. This is what's going to get hit if the condition is true. But what happens, how do we, for example, what if we want there to be always a console.writeLine that gets printed no matter what? But it will change exactly what it prints depending on whether this is true or false. Because at the moment, we're saying if it's true, print it, otherwise just do nothing. But if we want to still do something, how can we do that? And this is where we can use the else statement, or the else keyword. So else looks like this. We basically, at the end of the if block, so right after the end of the final curly brace in the if block, we write the else keyword, and then we give the else its own scope, of course, by giving it curly braces. And now, when the if is checked and the condition is checked to be true, if it is, of course, that gets executed. But if it's not, if this is false, then whatever is within here will be executed instead. So for example, let's have a look. I can copy my console.println, and let's just maybe change the text a little bit to say the result is greater than 25. Let's just delete that. Greater than 25. And then here I will say the result is not greater than 25. So now if I execute my code, we get the result is greater than 25, of course, because it's 30 at the moment. But if we go back again and change it back to 5, and now start up, we get the result is not greater than 25. So now we have two possible branches in our function, and one of them will always be hit. It's impossible to not hit one of these cases, because we're saying, if this is true, do it. Otherwise, do this. So now that we can actually specify conditions for the execution paths of our code, what happens if we have more than one? Right now, it's fairly simple. We only have one condition for this to be executed, which is, of course, result must be greater than 25. But what if we say this code should only be executed if result is greater than 25, but less than 30, for example? How do we go about achieving that? Well, that's actually very, very simple. And this is a concept known as chaining your conditions. So what we basically do here is let's just create another Boolean variable. I like to separate my expressions into their own Boolean variables because it makes your if statement a lot easier to read. It's generally good practice to do this. You don't have to, but I think you should. It's up to you what you do. But let's go ahead with my way for now. So let's create another one called is less than 30. And this is going to be equal to result less than 30. So, of course, the less than operator, we've seen the greater than operator in play. This is the less than operator. So now this Boolean is going to hold either a true or false, which will indicate whether or not result is less than 30. And how do we chain that condition? Now, how do we make sure that we only hit this block if both of these are true? Well, simple. All we have to do is, in our if statement, after our first Boolean variable here, we just do a space, and we put in a double ampersand, right? And this is a little bit confusing, I understand, but double ampersand just basically means and. Instead of doing a single and, you do two ampersands, because a single and is a bitwise operator. I won't go into too much detail about that. Just remember that you definitely do not want to be doing a single ampersand when you're doing this here. You need to use a double ampersand, which basically means if this condition is true and this condition is true. So now we're saying if my variable is greater than 25 and it's less than 30, then we execute this code. But if either of these are false, we will just hit the else case. We'll execute this code instead. So let's have a look at that. So if I go back to my old example where I had a value of 30, and previously it was printing because it was greater than 25, right? But let's see if it gets hit now. It doesn't. We actually hit the else case because our value is not less than 30, it is equal to 30. But what if we want to check if the value is less than or equal to? Because that's a viable thing to want to do, right? You might want to check if it's 30 or less. Well, simple. All we have to do is change our operator to be the less than or equal operator, which is simply done like this. So now our variable is less than 30, I'll call it is less or equal, and let's just change it to like this, and I'll do my control and my period or my full stop to get this little helper window, and I'll hit enter just to rename my variable. So now it's saying is less, oh, it didn't work for some reason. Interesting, Visual Studio. So now it's saying if is greater than 25 and is less than or equal to 30. Now if we start up, what happens? It now actually does indeed print the result is greater than 25. So I should probably change the message I print just to make it a little bit more obvious, but we can see here that that's getting executed now. So let's change the message that we print because we are going to be chaining different conditions, and I'll be showing you guys different operators, and we don't want to have to keep changing the message every time. So let's make it something reasonable now just to prove a point. So let's change it to, for example, the if condition was met. I don't know why I did capitals. The if condition was met, and then down here we'll say the else condition was met. So now we'll know if the if condition actually gets met, we will print this, otherwise we will print this. Now it's a bit more obvious. So I want to actually leave a few comments up at the top here just to remind us of all of the different operators that we'll be using for this episode. So the first one that we've already seen is the greater than operator, which looks like that. Then we've got the less than, which of course looks like this. Then we've got greater or equal to, which looks like that. And then we've got less than or equal to, which looks like this. So those are the operators when we're checking if two variables, in this case we're doing int, so we're saying, of course, if the one int is greater than the other int or less than the other int or whatever. But then when we want to chain multiple conditions or multiple expressions in our if statement, we will be using, we've already seen the and operator. So if I want to say condition, let's say we say condition 1 and 2, then we use the and operator. Condition 1 or 2, we will use the, I don't really know what it's called, but this is the or operator, but I think they're like pipes or whatever. Basically, you got to figure it out. But on my keyboard, it's the shift button, the left shift button, and the button right beside it, right beside the Z. But I guess it depends on your keyboard settings, so I don't know how you can print this on yours. But basically, this operator here means that condition 1 or condition 2 must be met, right? At the moment, we've only done an AND, but if I swap that to an OR, now this condition will be met if that is true or that is true. So I hope that makes sense. I think that's fairly self-explanatory, and that's pretty much all we need to do for now. Another thing, by the way, is that we aren't only restricted to an if-else like we have here at the moment. If we have another condition that we also want to meet before we go to the fallback case of the else, we can use the else-if combination like so. So we can put a condition in here. Let's say I'll say if result is greater than 30, so then we can say that we will print out the else-if condition was met. So what's basically happening here is at first the if is evaluated. So we say if my value is greater than 25 and it's also less than or equal to 30, then execute this. But if that's not true, then check, well, is the value greater than 30 though? And if that is true, execute this. But if that's also not true, then you just go to your fallback case of your else. So let's have a look at that in action. So we know at the moment our result is going to be 30 because we're 15 and 15 are getting added together. So we have already seen that we will hit this case. But if I bump that up by 1, let's just say the number is now 31. Well, we know that this is not going to get hit, but the result is greater than 30. So the next one should get hit. We should hit this else if condition was met. So let's have a look. The else if condition was met. So there you go. We can actually, you can see how powerful this can be. We can determine exactly how our function or our application should execute, depending on certain values that are either known when at runtime, or we can compile them at compile time. But as you see here, we've got an if, an else if, and an else. And I generally, if I'm using an if conditional check like this, I will usually try to keep it to these 3 only. Now you can go on and on and on and put in, you can put in lots of else ifs if you want. You can put in, a million else ifs if you want. It's up to you. But my point that I'm trying to make is try not to. If you can, try not to. Generally, three different branches like so are the limit for me. If you need more than that, you probably have a design flaw, or there are better ways to do it other than using else ifs. But it's good to know about it. It's good to know that you can do it. I'm not saying if you go over 3, you've done something wrong, but just if you do go over 3 in your code, it's an indicator that you should probably think about your design, or think if there's a better way, because there usually is. And so one final thing that I think I want to talk about is the concept of nested ifs. Now, don't be afraid by the term nested ifs. It's not as terrible as it sounds. But basically, when we talk about something that's nested in programming, we basically just mean that it's within something else. So if I have an if here, for example, and of course, this is the scope. These curly braces define the scope for that if. So everything within it belongs to that if. But inside, I can actually also put another if. And now this is called a nested if, because this if belongs to that if. This if will only ever get executed if that if gets executed. And only within what is within that if will be executed if its condition is met. Let's give it an example and then I'll explain it. So let's say if result, and here's another operator. Actually, we need some more operator up here at the top. So condition 1 is equal to 2. We use equals operator. I just wanted to add that up here because I did forget about it. So if we're checking for equality to see if 2 variables are equal to each other, we use the equals operator. Now, disclaimer, not always. There are cases where you don't. I'll talk about that in a future video because that is a bit more advanced. But for now, as far as you're concerned, when you're dealing with primitive types like integers and strings and bools and stuff like that, equals is what you want to use. So we use the equals operator, and not the single equals again. Like I said, it's important that you use the correct operators, because a single equals is used for assignment, as we see here. When we want to assign something a value, we use an equals. But when we want to check for equality, we use equals. All right. So down here, if I say if my result is equal to, let's say, well, we know it's greater than 25, but it's less than or equal to 30. So I can say if it's equal to 27, then I can just say console.writeLine. Oh, I don't know why I did a comment there. That was weird. Console.writeLine, and I can say result is equal to, and then actually I'll make this an interpolated string so we can nice and easily change it afterwards. I'll say result is equal to result. So now we have a nested if. So let's break it down. What's going on here? When we first execute this if, we say, is it greater than 25? And also less than or equal to 30? Yes. Okay, if it is, then we come into the enclosing scope of the if. But then the next code is another if. So now it says, okay, well, if the result is also 27, then we do something. Otherwise, we don't. We just skip it. We haven't specified an else case. So basically, we're just saying, just don't do anything. We just skip it. And then this piece of code gets executed anyways because the first if was evaluated to true. Let's have a look at that. So let's make a variable of 27, shall we? So let's just say I'll make this one 7. I'll make this one 20. So now our result is equal to 27. So what I would expect to see is a console.writeLine saying result is equal to 27. And then right after it, it should say the if condition was met. So let's have a look. There we go. The result is equal to 27. The if condition was met. So we've just achieved a nested if. And that's pretty cool. And that can go on for as long as you want as well. You can do 10 million ifs within each other if you want. Ifception. But probably not a good idea because you're complicating your code. Generally want to try to keep things clear and succinct as you possibly can. And we'll be talking about that a lot more in, I think, probably the next video when we talk about functions. But don't worry about it for now. We're just trying to prove a point, like I said. And we can also, of course, then say, but let's have a look at the OR operator. I talked about it up here, but we haven't actually used it. So we could say if the result is 27 or the result is 28. So now if either of these are true, then we will print that. So let's change it. So let's change this to 28, right? And start our application. You can see that it still prints our case because it still meets at least one of those conditions. The two conditions there, one of those are still met and evaluated to true. So this is the power of it, and it's very, very important to understand this because when you know how to control the flow of your application, you can create a very dynamic and robust application which changes at runtime depending on the user or depending on the user's country or what, you know, and many other variables. You can say my application should behave a little bit differently. And for an example of that might be an administrator. When the administrator logs into their application, they should have more power than a standard user. Or you could even say, for example, a user has a subscription to my application, and there are different levels of subscription. And if you're like the basic level, you don't get all of the same functionality as somebody who has like the pro package, for example. And by being able to branch your application and change its behavior depending on these variables, depending on these conditions and expressions, then you can control how your entire application works. So I think that covers everything for this video today, guys. As always, if you enjoyed the video, please leave me a like, a comment, and of course a subscribe. It would mean a lot to me to hear your feedback and to know that you guys are actually interested in following along. Even if your feedback is negative, I will definitely love to hear about it so that I can improve my videos for the future. So without further ado, I will leave it there, and I hope you guys have an absolutely wonderful day, and I will see you again next time.